All right, so here's our next illustration. I have a function here, garden variety little polynomial function here, defined on a nice simple little interval from 1 to 2. So there's no need to make this more complicated than it needs to be. And we're finding the integral from 1 to 2 of this function. And so one of the interpretations, this is not the only, but one of the interpretations is we are finding the surface area between 1 and 2, 1 on the left, 2 on the right, and then bounded between the graph of the curve and the x-axis. So let's see what this computation works out to be. First, we need the antiderivative here. Antiderivative is we have 3x to the third over 3, so we can say this is x to the third. The 3 divided by 3's cancel, and the antiderivative of let's just be careful here. Let's do this. I better show my work here. I don't want to take any chances. So this is 3x to the third over 3 minus 12x to the second over 2. This is evaluated from 1 to 2. We'll simplify that. X to the third minus 6x squared. All right? And so this is about as straightforward as it gets. Substitute the upper limit minus substitute the lower limit. So the upper limit is 1 to the third minus 6 times 1, 2 to the third is the upper limit. 2 to the third minus 6 times 2 squared. Then substitute 1, so this is 1 to the third minus 6 times 1 squared. 2 to the third, this is 8 minus order of operations. This is 4 times 6 is 24. So we have 8 minus 24 minus, and then this is 1 minus 6. So this is, 8 minus 24 is negative 16 minus 1 minus 6. Be very careful here. That's why I'm doing all this little detail work. There are enough negative signs in these problems to satisfy anybody's hunger. So all we're going to do is keep track of these negative signs. We're going to do each little detail one bit at a time. Keep your wits about you. It's arithmetic, but you do need to do it correctly. 1 minus 6 is, so I have negative 16 minus negative 5, not 15. And then minus negative becomes plus. So negative 16 plus 5, negative 16 plus 5 is negative 11. And you think, okay, big deal, negative 11. But remember what we said. One of the interpretations here is we are finding area. And a reasonable question is, but Regis, how can area be negative? Well, there are a couple ways this computation can turn out to have this value. The important part is the interpretation. Whenever this works out to be negative, there are two possible interpretations for this quantity being negative. One is, we've already seen, as you accrue area from right to left, that will be interpreted, that will be expressed as a negative number. We saw that on our previous example with the cosine. Well, we're going from left to right here, so that's not what's happening in this case. But if we draw the graph of this function, we see what's happening. Very roughly, very roughly, this is the graph of that function. And what we are finding is the area between the vertical line 1, the vertical line at 2, this is 1, this is 2, between the function and the x-axis. The difference is this curve is below the axis. If the region falls below the x-axis, that value will be returned as a negative value. Any area that's below the axis, this computation interprets it as that interpretation comes through as a negative number. If it's above the axis, it's positive. And if the curve goes both above and below, it's conceivable you might get some of both. And so that's why you can try this out on your own. You do the integral from 0 to pi of cosine of x. You notice in my previous example, I went from 0 to pi over 2. If you do this computation, I'm telling you right now, that works out to be 0. And it's not very hard to show that works out to be 0. 1, just do the calculus, and the computation gives you 0. But the other way to see it is this. That's the graph we're playing with. Here's 0, here's pi, there's the cosine graph. This piece is above the axis, this piece is below the axis, and they're symmetric. That area and that area are the same, except this is positive, this is negative. So when you add those two together, it's not too surprising that quantity turns out to be 0. And so that's what these, when you compute these integrals, it's possible that your answer is negative. And you need to be aware of that and be sure that you're interpreting this the correct way. If you are asked to find the area of a region, you need to be very careful about the graph that you're working with. Suppose you're asked to find, for some function f of x, the area between, the area on the interval a to b. And let's suppose that this is the graph of the function. Here's a, here's b. If you just find this integral, if you just do the integral from a to b of f of x dx, you will get a number. It will be a positive number. It is not the combination of those two areas. If you just do this integral just straight out, what you will get is this number will be returned as positive. Let's just pick a number out of the blue sky. Suppose this works out to be 8. And this will be returned as negative. Suppose this works out to be something, let's just pick a number out of the sky, that's -1. Then when you do this integral, your answer is going to be 7, which is not that area, and it's not the combination of the areas. It's because the integral assumes that you know what you're doing. If what you want is just this area minus that area, then 7 is correct. If what you want is this area plus this area, then you need to account for it in some fashion. A way to do that is this. You could now use the properties of the integrals. You could say this. Find this value of c, which is the x-intercept of the function. And now you can say, take the integral from a to c. That will find that area. And then take the integral from c to b. That will find this area, but that will be a negative number. This is going to be a negative number. And so if you want the combined total, then what you can do is subtract, because minus a negative will work out to be plus. If this blue region is 8 and this red region is -1, if you just go from a to b, your answer is going to be 7. But if you do this computation, what you'll get is 8 minus -1, which is the total 9, which is what you might have been looking for in your problem. The point is that not that you need to do this every time. The point is you need to be aware of the picture that you're working with and the integrals that you're finding, and the fact that if they fall below the axis, that will be returned as a negative value. If you're accruing area from right to left, that will be returned as a negative value. If the area is if the region is below the axis and you go from right to left, that's two negatives, that will return a positive value. You need to know what you're doing and be very careful that the picture you're working with is finding the piece that you are looking for. What you're looking for changes depending on the parameters of your problem. But you need to be sure to interpret the work in the correct fashion so that you find the piece that you're looking for.